Hello friends, welcome to Learner's Planet. Friends, in this session we are going to discuss ratio, proportion and variation. This is the very first session for the topic. We'll be covering the definitions and concepts of ratio, proportion, what is direct and indirect inverse variation. We'll be solving some problem on ages and then we'll be discussing chain rule. Okay. Friends, this topic is actually very important in case of entrance examinations, and definitely we are going to discuss more topics after that, that is percentages, profit and loss, time and work, time and distance. So this is what the basic of all these topics. So I hope you are having your paper and pen with you. So let's begin the session with me. Now let's see the definition of ratio. The ratio of two quantities in the same units. The important part over here, it is the same unit. Is the fraction that one quantity is of the other. It is written as A is to B. Here A is called the first term or antecedent and B is called the second term or consequent. Friends, the very important part over here, that whenever we are comparing two quantities, they should be in same units. Definitely different units cannot be compared. Okay. Now suppose I take an example. Maybe a place A is there, a place B is there and a place C is there. The distance between AB and AC, I have to make a comparison. Now the distance between AB is maybe 50 kilometer and distance between AC is suppose 100 kilometer. Now if I have to make the comparison of AB or AB and AC, what I'll be doing is I'll be finding the ratio of distance of AB to AC. So it is 50 is to 100, that is 1 is to 2. That means the distance of AC is double of AB. Okay. Here I can make the comparison since both the distances are carrying the same units. Now if the distances are not carrying the same units, can I compare them? No. Okay. Let's see. Suppose this distance AB is, instead of 50 kilometers, say it is 50 meter. Okay. In that case, AB is to AC. Suppose I write 50 is to 100. Okay. Now here this distance is in meter and this distance is in kilometer. Now suppose I simplify the ratio and write 1 is to 2. So what will be reflected, that the distance AC is double of AB, but it is actually not. It's actually not like that, because I'm comparing different quantities. So, and if I'm comparing different quantities, the wrong interpretation will be coming out. Okay, so that precisely whenever we are comparing two units, two quantities, they should be in the same units. Okay, so now what will happen over here? Just a moment. AB is to AC. Now AB is 50 meter. So I write 50 meter over here, and AC is 100 kilometer. So I'll be converting this kilometer to meter by multiplying 100 to 1000. So what I'll be getting? 100 and then 1000. Now we can simplify it. So it's 1 is to 2000. That means AC is 2000 times of AB. Okay. Now whatever the interpretation will make over here, it will be really correct. Okay. So I hope you are clear why we should compare the quantities with same units. Okay. Now to elaborate this, let me take one more example. Suppose there are two persons, say Ram and Shyam. Okay. Now Ram is having maybe 100 rupees and Shyam is having 1000 paisa. Okay. Now if we wish to find out how much amount Ram is having more than Shyam, suppose we try to find out the ratio of Ram and Shyam, what it will be? It's 100 is to 1000. That means 1 is to 10. Okay. That means what is the conclusion we are drawing over here? That means Shyam is having 10 times amount than Ram. Okay. This is Ram and this is Shyam. Isn't it? But actually, is it like that? It's not like that. Why? Why we are getting the wrong ratio over here? That's because we are comparing different units. Here Ram is having the amount in rupees and Shyam is having the amount in paisa. Okay, so if we are comparing different units, it won't give us the right results. Okay, so if we wish to make the real comparison of Ram and Shyam, so the units must be same. Okay, so let's see. Now let's convert both the amounts in same unit. It is Ram and it is Shyam. Ram is having 100 rupees. I wish to convert rupees to paisa, so I'll be multiplying by 100, and here it is 1000. Okay, so we just see over here that is Ram is having 10 times amount than Shyam. Okay, so in previous case what we were getting, that Shyam is having 10 times of Ram, but actually Ram is having 10 times of Shyam. So I hope you are clear with the importance of same units. Okay, now let's see the other terms. A square is to B square is called the duplicate ratio of A is to B. That means if a ratio A is to B is given, and if I wish to find out the duplicate ratio of it, that will be A square is to B square. Similarly, A cube is to B cube is called the triplicate ratio, and root A is to root B is called the subduplicate ratio of A is to B. Okay friends. Now let's see some properties of ratios. The value of a ratio remains unchanged if each of its term is multiplied or divided by same non-zero number. Suppose I have a ratio 3:4. Now any number, maybe x, I multiply to both the terms, still I'll be getting the same ratio. Okay, so whether I divide or whether I multiply doesn't matter. Okay, if A is to B and some positive number, A is greater than B and some positive number is added to each term of A is to B, then the ratio is diminished if A and B are positive. Suppose I have a fraction or a number or a ratio, I can say 3/4. If I add a positive quantity over here, then the value of 3 plus x by 4 plus x will be greater than 3/4 if x is positive. If x is negative, then 3 plus x by 4 plus x will be less than 3/4. Okay, and the same. Now let's see equal ratios. If A by B is equal to C by D is equal to E by F and so on, maybe other ratios are also there, then each ratio is equal to, that is A by B is equal to, or C by D is equal to, or E by F is equal to sum of numerators by sum of denominators. Even it can be difference of numerator by difference of denominator. Suppose A by B is equal to C by D, then each ratio will be equal to A minus C over B minus D. Or suppose we are having more than two ratios, say A by B is equal to C by D is equal to E by F. So whatever the operation we are performing in the numerator, the same operation should be performed in the denominator. So suppose it is A plus C minus E, then it will be B plus D minus F. In that case, each ratio, that is A by B or C by D or E by F, will be equal to A plus C minus E or by B plus D minus F. Okay, but operation should be same. Here it is plus, here it is plus, here it is minus, and here it is minus. Okay, I hope you are clear. Now let's see some properties of ratios. It is invertendo. The inverse ratios of two equal ratios are equal. That means if A by B is equal to C by D, then inverse of that, that is B by A, will be equal to D by C. Okay, then it is the next property is the ratios of antecedents and consequence of two equal ratios are equal. You don't have to worry much about the terminologies. You just see the concept, what we can do with the ratios. If A by B is equal to C by D, then this C can be taken as over, this C can be taken over here, and this A can be taken over here. So it is A by C is equal to B by D. That means B and C can exchange their position and A and D can exchange their position. Okay. Now this is very important property. If A by B is equal to C by D, then A plus B, that is numerator plus denominator by denominator, is equal to numerator plus denominator by denominator. That means A plus B upon B is equal to C plus D upon D. Similarly, that is dividendo, A minus B by B is equal to C minus D by D. Okay. If we combine both of them, that will be known as componendo and dividendo. That means A minus B upon, A plus B upon A minus B is equal to C plus D upon C minus D. Okay. That means here A is numerator and B is denominator. Here C is numerator and D is denominator. Okay. So this is actually very important property when we'll be solving the problems. Okay. Now next term, that is proportion. The equality of two ratios is called proportion. It can be written as A is to B in proportion to C is to D. Okay. Suppose I can say that is 3 by 4 will be equal to definitely maybe 6 3s are 18 and 6 4s are 24. Okay. So 3 by 4 is equal to actually 18 by 24. That means 3 is to 4 are in proportion of 18 is to 24. Okay. Now let's discuss the term direct variation. Now what is direct variation? Suppose I have two quantities A and B over here. Okay. Now one of them will be independent and the other of them will be dependent. In fact, B is dependent on A. Okay. Now there are two types of dependencies. If A is increased, then B is also increased, and if A is increased, B is decreased. Okay, so there are two types of dependencies. The first one, when A is increased, then B is also increased, is called direct variation. Okay, in that case, we mention it A is proportional to B. That means if A increases, B will also increase. Okay. The other one is indirect variation. That means if A increases, B decreases, and we show it as A is inversely proportional to B. Here A is directly proportional to B. Here A is inversely proportional to B. In this case, I would just revise it. If A increases, B will also increase, and here if A increases, B will decrease. Okay. We can take some practical life example of direct and indirect variation. Friends, to understand direct and indirect variation, let's take some everyday life example. You must be aware of the terms time, speed and distance. That is time, speed and distance. I'm just taking some practical life examples. And what is the relationship among these three? That is speed, that is S is equal to distance upon time. Okay. Now, what happens when distance increases? Initially, suppose you are going from A to B. Okay. And then you decided to go to A to C. Okay. That means the distance between A to B is less than the distance between A to C. That means distance is increasing. Okay. Now, if the distance is increasing and you have limitation of time, that means you need to increase the speed. Okay. Suppose you are having 1 hour or maybe 2 hours with you. Okay. In 2 hours, initially you have to cover the distance from A to B. Now in the same 2 hours you have to cover the distance of A to C. Now what would happen? You need to increase the speed. Okay, if there is a constraint of time. So what we can say, speed and distance are in direct variation. If distance increases, then speed will also increase if time is a constant. Okay, or if distance decreases, then speed will also speed may be decreased if time is a constant. Okay, now the other case, suppose I have a distance to be covered up from A to B is maybe 200 kilometer. Okay, and now I have to cover this distance in some particular time. Now I'm just seeing the relationship between speed and time. If distance is constant, if we increase the speed, then time will be reduced. Okay, suppose initially my speed was maybe 50 kilometer per hour. Okay, that means I'll be taking 4 hours to cover up this distance. Time will be 4 hours. Now suppose I increase my speed to be 100. Okay, that means now my speed is 100 kilometer per hour. Now what is the time I'll be taking? That is 2 hours. That means I'm increasing the speed from 50 to 100, but the time is reduced from 4 to 2 hours. Okay, that means speed and time are in inverse variation. That means if speed increases, time will decrease if the distance is constant. Now let's take one more example to understand the concept of direct and inverse variation. Members in a family and ration for them, okay, and number of days. Suppose we have 5 members in our family and we have ration for 30 days. Suppose there are 5 guests, that means we are 10 members. Now if the ration will be sufficient for us for 30 days? No. Okay, if there are 5 family members, the ration is sufficient for 30 days, and if there are 10 members in the family, then the ration will be sufficient only for 15 days. That means if the number of family members are increasing, the number of days this ration will last will be reduced. So these two terms are in inverse variation. If it increases, then it decreases. Okay, now let's take the example of direct variation. Now suppose there is a factory in which workers are making toys. So workers, toys and days. Okay, now suppose 10 workers are there and they are making maybe 20 toys in 5 days. Okay, now suppose days are fixed and we wish the production to be increased from 20 to 40, then definitely we need to increase the number of workers. That means if more work is there, more persons are required to do that if number of days are fixed. Okay, so that means these two terms are in direct variation. I hope you are clear with the concept of direct and indirect variation. Now let's understand variables partly in direct variation and partly constant. A very good example of this is your electricity bill. Okay. Now what happens? There are two types of charges on in electricity bill. That one is the rental and other is consumption of unit and unit consumption. Now this rental is actually fixed, maybe rupees 200 per month. And the other amount is charged on the consumption of units. Suppose we are consuming 50 units per month. And the per unit rate is say 5 rupees. So my electricity bill will be 50 into 5 plus rupees 200. Okay. Now in the next month, suppose I am consuming 75 units. So what my bill will be? 75 into 5 plus 200. Now we see this 200 is fixed and this amount is varying according to the consumption of units. Okay, so some amount is fixed and some amount is varying. Okay, similarly you can say your gas bill, water bill, okay, even your telephone bill. In all these cases, some amount is fixed and some amount varies according to the consumption of units. Okay. Now let's summarize and also see some important results. If A is proportional to B and B is proportional to C, then A is proportional to C. Okay. If A is proportional to B and B is proportional to C, then A plus minus B is proportional to C and AB is proportional to C square. Similarly, we are having more results over here. You just can go through them. Friends, it's not necessary to memorize each and every result. Whenever they are required, we'll be applying the same with common sense. Okay. I hope you are clear with the basic concepts of ratio, proportion and variation. Now it's time to discuss some problems. Let's begin with the first problem. Now let's see a very basic problem of ratio and proportion. Here we have been given A is to B is 3 is to 4. Now we have to find out the value of 2A plus 3B by 3A plus 4B. Okay. Now if A is to B is 3 is to 4, let's assume A is 3x and B is 4x. Now put the value of A and B in the given expression. So it's 2 into 3x, that is 6x, plus 3 into 4x, that is 12x, over 3 into 3x, that is 9x, plus 4 into 4x, 16x. It is 12 plus 6, 18x, by 16 plus 9, 25x. So we'll be getting 18 is to 25. See, in entrance examination, you don't have to show the workings. So directly you can put the value of A and B as 3 and 4 respectively. Since x is a common factor, which is actually not required while calculating this particular ratio. As at the end it will get cancelled like this. Okay. Now let's take another problem. Now let's see this problem. If A is to B is 2 is to 3 and B is to C is 5 is to 7, then we have to find out A is to C. Okay. Here the ratio of A and B is 2 is to 3 and the ratio of B and C is 5 is to 7. So we cannot make a direct comparison of A and C. If we wish to make a direct comparison of A and C, that means the value of B in both the cases should be equal. Okay. Now how could I make it equal? Suppose I multiply this expression by 5. That means this ratio by 5 and this ratio by 3. And then the value of B will be 15 over here and the value of B will be even 15 over here. Friends, we have already discussed in theory that if a ratio is multiplied by a positive number, that means if both numerator and denominator are multiplied by a positive number, the value of the ratio is not changed. Okay, so we can multiply this particular ratio by 5. So what I'll be getting over here is 5 2s are 10 is to 15, that is A is to B, and what I'll be getting over here is 15 is to 21. Now B is same at both the places, that now we can make comparison of A and C. So A is to C will be 10 is to 21. A is to C will be 10 is to 21. It's very simple, friends. Or you can go for an alternative approach also. I just write over here, it's A, B and C. The ratio of A is to B is 2 is to 3 and the ratio of B is to C is 5 is to 7. Now you should multiply like this. Okay, this 2 into 5, it's 10, then this 3 into 5, 15, then this B into this 3 into 7 is 21. So the ratio of A is to C is 10 is to 21, that is option A. Okay, I hope you are clear with the method. Now let's take the next problem. Now in this question we have to find out the fourth proportion to 3, 7 and 15. That means the ratio which 3 and 7 is maintaining, the same ratio should be maintained by 15 and some other number. That means 3 by 7 is equal to 15 by x. In that case we have to find out the value of x. So x will be 7 into 15 by 3. So x will be 35. Okay, so whatever the relationship is between 3 and 7, the same relationship will be between 15 and 35. Okay friends, I hope you are clear. Now let's see this problem. Here we are given A is to B and B is to C, and we have to find out A is to B is to C. Similarly as in the previous problem, I just write A, B, C over here. It's 5 is to 7 and it is 6 is to 11. Now just do it like this. So 5 into 6, 30, 7 into 6, 42, and 7 into 11, 77. As simple as that. That is 30 is to 42 is to 77. Okay friends. Now similarly in this case we have to find out the ratio of A and C. So let's write A, B, C. It's 3, 4. It's 8 is to 9. Okay. So 3 into 8, 24 is to 32 is to 4 into 9, 36. Okay. We can simplify it. It's all the terms are divisible by 4. So 4 6 are, 4 8s are, and 4 9s are. So we have to find out the ratio of A and C. That is 6 is to 9. That is 2 is to 3. Okay, 3 2s are 6 and 3 3s are 9. Okay, I hope you are clear. Now in this question we are given A is to B, B is to C, C is to D, and we have to find out A is to D. Now A is to B is 8 is to 15, B is to C is 5 is to 8, and C is to D is 4 is to 5. Now here C is 8, so we can convert this C into 8, so it will be 8 is to 10. That means B is to C is to D will be 5 is to 8 is to 10. B is to C is to D will be 5 is to 8 is to 10. Okay. Now here B is 5, here B is 15. So I can convert this 5 also into 15 by multiplying this expression or this ratio by 3. So it will be 15, 24, and 3 5s are 15, 3 8s are 24, and 3 10s are 30. Now A is to B is 8 is to 15, and B is to C is to D is 15 is to 24 is to 30. That means A is to D will be 8 is to 30. Or we can say it is 4 is to 15. Okay, this is the correct choice. Or alternatively, you can do like this. First of all, you just find out the ratio of B is to C is to D by the method which we discussed in the previous question. It's B is to C and D. Okay, so it's 5 is to 8 and 4 is to 5. So it's 20 is to 32 is to 40. That means the ratio between B and D is 1 is to 2. Okay. Now A is to B is to D. A is to B is 8 is to 15, and B is to D is 1 is to 2. Okay. So it's 8 is to 15 is to 30. That means 8 is to 30, that is 4 is to 15. So this is a smart way or a short way to know the problem. I hope you are clear with the concept. Now let's do this problem. if 2a is equal to 3b is equal to 4c, then a is to b is to c. Okay, now what is the LCM of 2, 3 and 4? That is actually 12. So let's divide each term by 12. Okay, so it's 2a by 12, that means a by 6 is equal to 3b by 12, that is b by 4 is equal to 4c by 12, that is c by 3. That means the ratio of a is to b is to c will be 6 is to 4 is to 3. Okay, a is to b is to c is 6 is to 4 is to 3. Okay, this is the correct choice. Okay, let's see the next problem. Now in this question, a by 3 is equal to b by 4 is equal to c by 5, and we have been asked about a is to b is to c. But obvious and quite simple, the ratio will be 3 is to 4 is to 5. Okay friends. Now let's see this problem. Ratio of 4 raised to 3.5 is to 2 raised to 5. Now 4 can be written as 2 raised to 2. So this is 2 raised to 2 into 3.5, that is 2 raised to 7. It's to 2 raised to 5. So it's actually 2 raised to 7 minus 5 is to 1. That means 2 raised to 2 is to 1. That means 4 is to 1. So this is the correct choice. Friends, we'll be doing more problems, more difficult problems in fact in our next session. By that time you just revise this particular session, so you'll feel more comfortable in the next session. Okay, all the best and bye-bye.